Hey everybody. Um, Guess we'll give everybody another minute or two to join. Seems a little light today. Okay, I think we got everybody now. All right, so we had a discussion about testing last time, so I went and looked in the other docs about what's being specified in terms of tests, and so there's nothing in the in the link layer spec. Um, But in the Bow 5 spec, obviously we knew there were patterns. So I checked to see exactly what we're defining there. And it actually does talk about supporting pseudo-random generators, but it's, it's worded differently than what we had in our spec, which is stuff we were talking about crossing out last time. Um, and it seems it seems optional, obviously, also in the bow spec. So actually, one second. Can you guys hear me?
Yep.
Yes.
I am not hearing you. Okay, one moment. Let me make sure my audio is not messed up here. Okay, can you guys hear me?
Yes, we can.
Okay, all right, thank you. Sorry, thought I messed something up there for a minute. Okay, all right, back to where I was going. Oh, wait a minute. There it is. Anyway, all right, back. So the BOW 5 spec does actually have pseudo random generators in there. Um, I'm a little unclear on whether this requires hardware generation on the transmit side. Does someone, or whether, so right now our testability in the control path spec requires a set operation, which is defining the explicit pattern which is going to be transmitted. And in order to run a test, the way we have it worded is you must do a set and then you do a run command. Do these pseudo random generators, are those hardware generators that are that you don't set a pattern, you just set parameters, or does anyone know how these are actually implemented in the FIs?
Well, I can certainly talk about how we implemented them at Blue Cheetah, if you'd like. I don't know what the specifications like require.
Yeah, well,
Uh,
that's the problem. I'm not sure whether the specification requires this or not.
you said it's mentioned to be optional here?
Well, it says it should. So users of the systems should check that one or more of the test patterns supported in the TX is supported in the RX. So actually, it doesn't require any of these. It just says it has to be the same one. Such pattern generators slash checkers should therefore support the following patterns. And again, there's a lot of shoulds. Um, and then it
Yeah.
talks about pseudo random 9, pseudo random 31, and then isolated 1 and 0 pattern. And so from the control path, we're just doing a set and run test without any kind of specific algorithm. We talk about the algorithms in our thing, and we crossed that out last time, but and part of the reason we crossed them out is there's nothing in our spec that actually requires a specific algorithm other than that statement. So anyway, let's talk about this real quick first. What is Blue Cheetah doing here? Are you guys using hardware or you're just doing something outside of the PHY?
Yeah, so we're using hardware. We have um per lane PRBS generators that support 9 through 31 with a bunch of also stuff in the middle there, like 15s and 23s, I think, as well as I think it's now a 64-bit memory pattern generator. So you can put in any static 64-bit pattern that you want in addition to the PRBS patterns.
Okay.
Sorry, I forgot for the PRBS stuff, we also allow you to set the seed in the generator to be an arbitrary number so that again, we have different we have, if it's 16 or 18, depending on whether you have, FEC and aux, we have an individual generator for each lane and you can seed them differently and then start them up, in at the same time concurrently so that you can get, kind of different patterns if you want on the different lanes to talk crosstalk and stuff like that. So
Gotcha.
that's our PRBS stuff is that, it's per lane. It goes from 9. I think we even do a 7, sorry. I think we go down to 7 as well. Um, but anyway, we do the 9 and 31. And again, with the additional thing we have here beyond what's stated is the ability to individually seed each PRBS generator
Uh-huh.
to be different. And then on the deterministic patterns, again, we have a 64-bit, arbitrary static pattern that can be sent out again on each lane.
Okay. All right. So you have a lot of flexibility, it sounds like, and it's
Yeah,
all hardware supported. So it's not like just load registers and for each individual pattern. So
that's right.
okay. So here, let me switch over to RDoc and talk about what we're specifying, or we're specifying the control of, which is really the important part.
Yeah, so if I recall the discussion correctly, right, back in the days when this was discussed in the FI meeting, I think one of the PRBS was required, especially if you want to do real-time eye plotting. So you will need something to generate random traffic. And then the fixed traffic, I think that is configurable. We discussed whether we want to make it like a spec defined pattern, but I don't think we discussed anything beyond that, and we just decided to keep it programmable so that if two vendor implementations require a different expect a different pattern, then you have CSRs to go and override it.
So right now, from what I understand, we just do do we do an RX defined 16-bit pattern? Like you load RX loads the TX with a pattern, hits transmit. That's all we support right now.
I believe it is a 64-bit pattern.
Oh,
I
is it
think you need
64?
at least 8 bits to so that the other side can so that the RX can know that there is something changing and it's not stuck.
Okay, all right.
And
Well,
that's required for the lane calibrations, required for some of the steps in the RX calibration.
okay. I guess my question is do we need to add anything in order to support running the pseudo-random generator from either side? Because we talk about it a little bit in this text I crossed out we were talking about last time, but we don't
Right.
actually have any controls.
Yeah. My opinion is that, whatever hardware needs to be there should be talked about in one place. And if the PHY spec's going to do it, then we should let the PHY spec do it and not try to like usurp them or anything or overwrite them.
Oh, I agree. That's not my point. Well, again, our point, my opinion is our focus should not be defining new requirements for the PHY. Our, but we do need to talk about how we control those things since we're the control path for that. So
Right. So again, why do we say in that first paragraph a 16-bit sequence, right? If you're saying that we shouldn't, overwrite what the PHY is saying, then we shouldn't be stating any kind of
I see.
requirements for hardware.
I see.
Right. I mean,
Uh,
I think from a link layer perspective, I think the only thing we probably want to define is if we want to send something that is on a per link level, the PHY will implement something that is for individual PHY lanes. But at the link spec, I think if we want, we can add similar capability to inject PRBS pattern at the entire link level and not individual lanes, if that is desired. So that's something that I have done in the past, where in addition to what the PHY supports with respect to PRBS, we had a similar PRBS implementation at the link layer that would generate traffic across the entire link. And that link could be using multiple PHY slices. So we generate the PRBS and spread it across multiple PHY slices. So, but I don't know if you want to add that as a link control path spec for debuggability, or do we just keep it optional?
Right. But shouldn't that be in the link layer, the transaction link layer spec then? Not here. I mean, this is sideband specific stuff.
so to be clear, that the transaction link layer spec has nothing on testing at all right now. And this will go into the link layer spec, but we don't right now. That's not part of the scope. With all of the testing patterns and stuff like that are in the Bow PHY spec. Which is the thing I just showed. And that's, oh, and to be clear, like aside from loop back and stuff like that, in terms of just the patterns, that's all the information the Bow PHY spec has. Those were the patterns, that short little paragraph. So, okay, so we have two problems here, it sounds like. One, it sounds like we're defining a testing capability in terms of loading patterns and playback that is not mandated in the PHY spec. And at least from the control spec, that's all we're really doing. Like that is our testing commands from what I can tell in the PMR is load pattern, play pattern. And then the other side of it is we are somewhat mandating the pseudo-random generation in the PHY spec, and then giving no capability of controlling the pseudo-random generators in the control path spec.
I thought the PHY spec mandated PRBS 9 and 31 at the minimum, if I recall correctly.
Well, that's
I
what
don't
that's what I was just sharing a minute ago. Yeah, yes, it shows you should support one of them.
Right, and I think that is required because that is the only way to plot the I for the PHY at runtime in the lab. So I think that's the reason why they mandate at least one of them.
Okay. Again, back to my point. Whether it's mandated or not, we've got no control registers for them. The question is do we need control registers for them, or we're just saying vendor specific, and on the other side, we're providing control for something that is not mandated right now.
That's not true, right? We do have control registers, but they will be in the file register space. So if you go back to the register map table, there is a section where we want to put all the file registers and the control
Right.
registers for
Yeah,
triggering
there's
those
no
PRBs.
addresses, there's no registers defined. It's just, okay, here's an address range. You can stick some registers. That, to my point, in my mind, that is vendor defined. We're just giving you a bar for it.
Correct. So yes, I mean,
But
back in the
that's
day,
not, so shouldn't that be in the PMR side?
it doesn't have to do anything with the PMR, right? Because PMR is something that is completely sideband. So this would probably, I mean, I would probably agree with Paul that the section that we are trying to discuss about
Okay,
is
hold on, Ron. What, my interpretation of what this spec is for is this is the sideband communication path so that one side can set all of the stuff it needs to on the other side for the main band, right? This seems like a very important piece of the main band that you would need to be able to communicate it across the link. I'm a little unclear on where we're defining our realm of responsibility if we're not covering this.
no, I believe we
Yes.
have a PMR for setting or for telling the partner what to transmit.
Right,
Um,
right. Again, so that's fine. Okay, so there's again the two we have two commands, right? We have set and run, right? And we actually even talk about specifically in some of the constraints that if you're going to do a test run, you have to do a set right before, which is fine. But I mean, to Paul's point, that specific capability is not defined in the BAO spec. Personally, I think that's a pretty light requirement here, and I don't have a problem with it. But we need to make sure that we're comfortable with that capability that we are requiring from our side first.
Can you show the set and the run PMR
Yeah,
commands?
they're just
Brian? Did we lose him?
Oh, there he is. He's back.
Can you guys hear me now?
Yes.
Okay, sorry, I didn't realize I cut out. Maybe my internet's getting flaky again. All right. So yeah, so here it's all in the PMR address space, which is again why I'm saying this falls in our purview again too.
Oh
We
no,
have
I'm definitely with you there, Brian. It does. We definitely have a way to control the hardware. I'm with you 100%. So I'm sorry if I didn't imply that before. Um, but yeah, we need to be able to like control that hardware through sideband.
okay,
And so
so from the command point of view, we have all these commands here for setting and then that we're comfortable imposing this capability on everybody, which again, this doesn't
so
seem like
Brian, your internet went away for like the last 30 seconds. We couldn't hear anything that you said.
great, great. You know what? Let me dial in my phone. 1 second. Okay. Can you guys hear me?
Yes.
Okay. All right. So let me restart again. So we have commands for setting the pattern and playing back the pattern, right? And so, as you were saying, Paul, a minute ago, it's not an explicit thing that was in that list that we just saw. So we are adding a new requirement, but it sounds like we're okay with that requirement, right? Imposing that requirement on the BOW phi spec effectively, right? And so then the question then becomes,
Okay, I missed,
what?
sorry, Brian, I missed that imposing requirement on the BOW phi.
Okay,
What is the, what is that?
let me go back and reshare the BOW phi spec.
We're imposing the same requirement that exists in BOW phi on the link layer?
No, so the BOW phi spec is talking about these patterns here in terms of testability, right?
Yes.
Talks about pseudo random, and it talks about some
And yeah, I follow you
wondering
there.
that test things like that, right? And then these seem to be mostly hardware generated tests, right? We are
Yes.
imposing, our testability is the RX side sets a arbitrary pattern that it defines and then requires a playback, right? Which isn't a very hard requirement to meet, but it is technically a new pattern, a new requirement on the BOW phi. Does that make
Right.
sense?
My reading, Helia, is this spec we're looking at right now does not state the need for a 16-bit deterministic pattern. And we
Okay.
are
Like
in the sideband.
I can add some flavor to this if that helps. So the original workflow that we discussed when adding these sections was so when we send the PMR, if you can go back to that PMR PMR spec. Yeah, so the intended workflow is you set the PMR to set up a certain pattern and you send that PMR to the partner. When the partner receives that PMR, the software is going to go and read the PMR and decode what is being requested. And say the PMR said, based on the PMR, we want to set a certain lane to start transmitting a certain pattern. The software running on the partner knows what TX5 register it needs to program in order to accomplish that step. So that was the whole motivation behind not mandating any of the 5 CSR space as a spec defined structure rather than a vendor defined structure. So in general, back in the day, people wanted to keep BOW very flexible as it can get. And there was a lot of pushback in even defining certain CSR maps as mandated by the spec. They wanted to keep all the CSR maps flexible. So in this case, we decided to keep the 5 CSR map flexible. So each vendor can define their own CSR map. But then what is spec defined is the PMR instruction to send to the other side, so that the other side understands what it needs to do. How it needs to accomplish that is vendor specific implementation that the other side already knows, and they can implement that in their software routine to go and set the right register in the file to accomplish that task, and then send an acknowledgement back. So that was the whole motivation behind not adding all of those 5 registers that control the testability of the lanes into a spec defined CSR map, if that makes sense.
So, well, we have like half the registers though, right? So we do have ability to like set. We have ability to set seeds and things like that.
Right. So we are not actually directly going and writing to the. I mean, if we want, we could directly instead of going through the PMR, we can potentially also directly go and write to the respective TX registers. But anything that goes through PMR does not actually go and physically access the exact CSR that needs to be written. all PMRs are interrupted to the software, and then the software comes and does what it needs to do.
That's
So,
fine. That's absolutely fine. I
right.
mean,
So
but we all know there's a software interpretation layer or firmware interpretation layer here. The question
correct.
is what we have adequate to communicate what we want to do?
I
And are we
believe
not,
so.
and we need to make sure that we're not adding unwieldy requirements on top of what's already on the PHY spec. So
Okay, so I would like to hear your
let's
thoughts about what you feel is missed, right? So, say for example, in this case, we are asking the transmitter to asking the partner's transmitter to transmit a certain pattern. So, and then this goes via PMR, so it's all software interpreted.
yeah.
So, do you see a hole in here where we want to mandate something?
Right. So I guess my point there is like, okay, so again, to Paul's point, the arbitrary playback. Let's talk about that first. Are we okay keeping all of that here? Sounds like yes.
To me, it seems that this defines a general pattern that has allowed ROM to make that very specific implementation that you just walked us through. So to me, it seems yes.
Okay. And then so the other side of it would be the pseudo random side. We talk about there's a way to set a seed for the pseudo random, and there's a way to basically press go on pseudo random. But we don't have any other way of giving control bits that I see for the pseudo random, like picking which pseudo random algorithm is being used or anything like that. And even if it's vendor defined, the exact algorithm that's being used and etc., we don't have any kind of. It would have to be another totally vendor defined instruction in between those two things in order to actually run the test. Does that make sense?
Yes, I believe that for the pseudo random, it is the PRBS type and seed. I think both of them need to go. Maybe I think that's what is probably causing the confusion is if there are more than one pseudo random implementation, then we will want to select one of the two. And the reason why I mean I'm just speculating here why we didn't add that before was because the 5 spec mandated only one or the other pseudo random generator, and then at the time of writing the software would know the pseudo random capabilities for the partner, so it can set the expectation correct at the higher level. But I understand. I mean, if multiple designs can support 5 different PRBS types, then we'll probably need to also specify what PRBS we want to transmit in addition to the seed value.
I
And
guess
and
that brings up a question. Do people change that on the fly? Is that something that we need to is it acceptable to say run pseudo random and you and this both sides agree, oh, this means, PRBS 9, or it means 16 or whatever the case may be, right?
Yeah, I mean both sides have to agree, otherwise the PRBS will never lock. So if the transmitter is sending PRBS 9 and the receiver is expecting PRBS 31, they will never lock onto the PRBS pattern. I mean it is implicit that both sides would agree. But I think back in the day, not many implementations were even supporting a lot of PRBS patterns. So yeah, I mean if if we want to support all of those implementation, then either we say at a higher level, both systems agree what is a PRBS that's going to be used, or we add this into the spec here to pass the PRBS type along with the seed. Paul, does that make sense?
No, it does. I'm just trying to understand what we have to date. Do you folks feel like you understand what these set commands do? Because I don't, to be honest, I don't see the ability to do the things I need to be able to do. Like I think there we can set the seeds, right? If you look at what the fifth guy, sorry, 1, 2, 3, 4, the fourth guy down in the set stuff, right? That says set PRBS seed, right? For a given slice, it seems like. But for some reason, the second to the rightmost column is all zeros, where that's normally the bit ID, which I assume is the lane ID. So again, I need to be able to set the seed individually to each lane. And if that were like bit ID, so again, if you go up a couple rows, right, we have bit ID for some of the 16-bit patterns. I assume that means the lane. Rom, do you know? Is that bit means the bit of the data bus? So I can individually set the 16-bit test pattern on a per lane basis for the first row of the set stuff. Do you know, Rom?
Can you scroll up to show what is the column title?
Hold on a
Oh,
second.
it's
Let me
all
just let me, let me, let me hold on
wow.
one second. Let me just move this down. There we go. All right, so it's
Primary,
field
secondary,
2A. The way we define field 2A up here is link or bit ID where relevant.
Yeah, so that would be, I mean, if you're doing it as a slice, I think that would be treated as a bit ID, I believe.
Okay, and that means which bit of the data bus?
Which bit of the data bus? So it's individual. So you can go and set this pattern at an individual lane granularity
Cool.
if
Okay, so
required.
now, right. So my question now for you, Brian, right, is like, well, why did we zero out the bit ID for the PRBS seed? Right? Why we always make it be zero? Right? We need to be able on a per bit basis. I'll call it per lane basis, right? We need to be able to set the seed. So I don't know why that, as long as if we change that zero to be bit ID, then I think we have the ability to individually set the seeds as I need to in the transmitter. You following what I'm saying?
Yeah, yeah.
Okay, but so for each lane, but now, however, once you go to a PRBS that's bigger, right? The LFSR is bigger than 16 bits. Now you need more seed bits, right? You can't seed properly a PRBS 31 with 16 bits,
Paul,
right?
one clarifying question. That is row 1. Is that what row 1 does? So I'm looking at row 1 versus row 4. So it says set a slice K be J.
Right, but so my interpretation is the first 3 rows of this section are for the deterministic pattern, and the final 2
Okay.
rows of this section are for PRBS. Now I may be wrong because again, that's why I'm asked why I wanted to see this because I've not looked at this in a long time. So I don't understand. Like my original thing is I don't understand what this is saying. Right, I'm trying to decode it for all of us so that we can either agree that there is enough information here or there's not. And until I understand what's here, I can't answer that. But yeah, no, hell yeah, my impression is the first 3 are for the deterministic pattern.
Okay, then I understood. Yeah, that makes sense. Yeah, I'm following you.
So my point is, once we have a PRBS bigger than 16, one command is not sufficient. We've only allowed field 1 to be 16 bits wide. So I understand in each one of these PMRs, we only communicate 16 bits, but that's not sufficient for our needs.
Yeah, I think it's implicitly saying the same pattern for all the bits, I think. Okay, so
Right.
so it sounds like we have 2 problems. So number 1, you want to be able to specify a seed on a per bit basis. And then the other side of this is that the seed isn't necessarily large enough for your implementation.
Correct.
Or
Well, at
for,
least not even mine, right? For BOW, right? We're saying you can do a
yeah.
PRBS 31.
So we need another instruction probably.
Right. And then I believe the last row is what we were looking for before, right? This is saying, okay, I'm running a PRBS pattern, and this is the test pattern, which to me is the length of the PRBS that you want to run. And again, this needs to be on a per bit basis. So that 0 should be replaced by bit ID.
Okay.
Is it the length of the PRBS or PRBS ID?
Well, again, you know, I don't think we want to support in the standard multiple different PRBS patterns for a given length, right? If we do a PRBS 7, it's going to be this PRBS 7. And so length and pattern are kind of the same, right? They're not, there's no difference between the two.
Yeah, I believe the reason why we have a pattern ID is because we could also have a fixed pattern. So we want to be able to select between whether we are sending a fixed pattern or a PRBS 9 or a PRBS 23 or a PRBS 31 or whatever that is. I think
Right.
that's the
Okay.
reason
So
why we-
this pattern ID is effectively a, a test number. Is that what we're saying?
in some sense, I mean, if you're considering each PRBS to exercise a test, then yes. But what it basically selects is out of the different pattern generators on the transmitter, what pattern generator you want to activate. I think that's what
I
it
see.
specifies.
Okay. Yeah. So this was not clear at all to me then. Okay. All right. So there's a couple of things we need to do here. All right. So both of these need to be bit IDs, right?
Yes.
Okay. And then we need to add. So if this pattern ID is actually a test number, right, which is kind of where I was also talking about, right? Then that needs to be clarified as well.
Correct. Right. And then if what Ram just said is correct, and I don't doubt that it is, then we don't really need separate commands for setting the seed and setting the 16-bit pattern, right? We're only going to send either a 16-bit pattern or a PRBS seed or a PRBS pattern. And therefore we could put that constant in the same field, right? We don't need to have an individual like row 1 and an individual row 4, because the test pattern ID is going to tell us whether we're going to doing a deterministic pattern or a PRBS pattern. So therefore, you know, we can like combine 1 and 4 together and be just the, you know, initial value of this test register. And then now we get like our 32 bits that we need. Right? One could be for the lower 16 bits and one could be for the upper 16 bits, instead of one being for the deterministic one and one being for the PRBS one, if that makes sense.
I
Right? If we have,
agree.
okay.
Okay, I see what you're saying. Um, but we don't have. There's not a way in the. Oh, okay. Are you saying in terms of this field making it upper and lower? Sorry, the secondary. But how do you?
No,
So there's only one pattern that you're loading in here, right?
right. That was my point, right? Is that you either need to load in the deterministic pattern for the 16-bit job or do, or you need to load in the seed for the PRBS job or do, right? You
Yes.
never need to do both. And so therefore having separate commands is kind of like inefficient, right? What I need is I need another command to load the upper 16 bits
Right.
of my PRBS seed. I'm saying I found that now because I don't need to have these be per pattern. I can combine them together, right? The row 5 will tell me the test ID I'm going to be doing, right? So that will tell me whether I will be using the 16-bit pattern or the PRBS pattern, right? I don't need row 1 and 4 to tell me that.
Okay.
So therefore I
So okay.
combine 1 and 4. So we
Yeah.
just need to
So
rewrite this, I
basically,
think.
instead of having 1 and 4 as they are, do one upper, one lower. What I got a question also, I guess on the same note, what is this one doing at all? Because it does the exact same. It says all bits in a slice, yet it has bit ID. Was that supposed to be zeroed out? Well, that actually wouldn't be zeroed out. It would be. Is there another bit I'm missing? Oh, I see. Here it is right here. Never mind.
Yeah, no, so bit ID is superfluous there, right? If you're doing all bits, you don't need a bit ID. So I'm with you there, Brian. That's like that should be some constant number, not bit ID.
Okay.
because you're doing all bits in a slice, right? So that just is a shortcut to like not have to do bit ID 16 times.
Yeah.
Right. Right.
Okay. All right. So I get where you're coming from, Paul, on the upper lower. Is everyone in agreement there? I mean, is there not? I'm going to make sure we're not stepping over people's toes in terms of being able to set these patterns individually.
היי אורי, אני הולך.
Okay. All right. Let me think. Okay. So, all right. Rather than make a bunch of comments, I'm just going to do a live edit here, and we'll see where we end up here.
ביי.
Yes. Ty, I think you're off mute there. All right. Set the 16-bit pattern. Here, let's just do this. I think the way that we're using the primary and secondary looks fine. So slice K, bit J, set um does that make sense?
Yeah. I mean, it does
Oh,
to
and then
me.
we
I
need
would
the
move
bit
it
ID.
up to the, I would move, well, yeah, and I would move it up to be the second row of this column. Makes a lot
Yeah.
more sense to put them adjacent.
So what do you think, Ron? Do you have any issue with this? And it also sounds like we need to add some text to make this a little more clear too, and exactly what's going on here.
Yeah, definitely whatever's in that first column is insufficient, in my opinion, to adequately describe what's going on.
Yeah, I'm fine with this. I think we can probably also potentially reclaim some bits from other columns, but yeah, I think that would probably make it more complicated. So I think this is a good middle ground to specify things in this.
Right, right. So now, so I like this a lot. This is a big improvement. Again, I'm with Ron. Maybe we want to adjust the address bits to be more, consistent or whatever, or flow, more properly. But
If one of you guys wants to make a suggestion there, I'll make the edits after you guys make a suggestion rather than me messing around with all the address bits.
okay,
Um,
but more importantly, right? Now that we've done this for this first row, we need to do the same thing for the third and the fourth row, right? We still only have the ability to do all bits in a slice and all bits in all slices only for the lower 16 bits.
Yeah. I'll do that offline. I think that so I think one big problem with this table is the first column is kind of an overloaded name slash name slash description, and we don't follow up. So I feel like we need, so like some of them are, I don't know. This whole table has been bothering me for a while. What do you guys think? Should we break up this table into multiple sections so that we can add descriptions to each of the things and make them a little more readable?
Yeah, I like that
Or-
idea. Yeah, I
Okay.
don't know if we need to break the table up or not, but we certainly need, paragraphs of descriptions about how we expect these commands to be used.
Okay, so I'm going to break them, tentatively at some of these gray spots, maybe move some things around and add little paragraphs that, for some of these things so that it's a little more readable and a little more understandable. Or we have more flexibility, at least in terms of adding more stuff. Here, let me add a comment here. So I remember to. And what was I doing here? Oh yeah, I'll go ahead and just change this. Okay, yeah, and then in the text, I'll talk about the pattern ID being a pre-known test between the systems.
One more thing quickly. In row 4 now, what you have is in row 4.
Yep.
We should probably zero out slice ID.
Oh, all slices. Yeah. Okay. Okay. All right. Okay. So this will also need to cause me to reword some of the things I have up here. But again, this is kind of meant to be covering everything. So it'll probably get broken up when we break up the subsections too. Okay. Well, I'll take a stab at it and then we can discuss next time whether that breakup and rewording is accurate, is adequate. Okay. All right. Before we run out of time, let's see. Let me double check what else. There was some other changes I made. So I kind of did some rewording throughout the spec on everything that let's see. Oh yeah, this also, I think we're clear now exactly where things are, but there's, as I mentioned earlier, there's actually nothing in the TLP spec. Under, where was this? There's, again, just some, so, okay. Again, I talked about this last time about separating out some of these things. And I think I broke this table here because some things are mandated and some things are kind of optional. We're just kind of setting bars for some of these registers. What was I thinking? What was I saying? Oh yeah. So we had this column here had, I think it said TLP spec / VOW spec or something like that. And I just want to point out again, there's no addresses in either one of those specs. So I just put implementation defined on all of these because there is no actual, other than us setting the origin to where these register spaces start, we don't, nothing else is defining any kind of naming or or exact registers that even need to exist in these things. So I just put implementation defined on all this stuff. Changed some of the wording here around bit 59 because it was kind of confusing. And then yeah, minor changes through this stuff. Okay, so that's not a big deal. Anyway, so I'm going to break this up as my next action item here and start adding some text, and then people can, if you guys want to change any of this address shuffling, bit shuffling, please take a look and let me know what you guys think makes sense, and I can do some minutes around that. I don't have any specific ideas on what other fields might need some more bits right now. We do have a number of reserved fields, so again, if we need to move bits around, we've got bits to move. We do have a separate command for running the pseudo random versus the deterministic. I guess, you know what, I think that's probably still fine because it can be, the pattern ID can mean something different can be overloaded in terms of can be overloaded depending on the command. And we can talk about that in the text. Is there any other commands that we need to call out real quick before we end the call here? On by transmitter offset transmit pattern on slice K. So these tests right here, the eye training and the offset transmit, I mean, those are implementation specific, right? Those patterns. Like we're not defining those patterns specifically in another spec. It's just whatever the system knows that those patterns are, right?
Sorry, I don't know.
I believe they are going to be vendor defined. So yes.
Okay.
But I think maybe we have some redundancy here because if we are already having PMRs that are that we are enabling capability to select a pattern and to select per individual bit lane, then there is some potential to merge the two and keep just one section that describes um, instructions that tell the partner what to transmit on a TX.
Right. And this sounds like, you know, like a shortcut, something that's, you know, do the thing that we already know you want to do or whatever, right? It's a predefined. It's instead of individually setting the patterns, it is setting all the pseudo random pseudo random patterns. It's doing something that's already known.
Right, and I believe BAPI split it out just because there is also a field that describes the stage number, and doing the RX calibration happens at a different stage number. I believe that's the reason why he has this at a different row. But yeah, I mean there is a good amount of opportunities to consolidate this table and make it shorter.
Okay, and then we can talk about that next time. Like I said, I'll cut it up and add some wording, and maybe that'll give us some more visibility into what's there, or what's possibly collapsible, or what's a little too redundant. All right, well, thanks, guys. I think that's probably all I have for today. Anybody else want to bring anything else up before we end the call?
From me. Thank you.
All right, thanks, guys. See you next
Yeah.
week.
Thanks,
Thank
Brian.
you.
Bye-bye.